Okay, guys and gals, today we're going to talk about exponential equations that require logarithms for solving. This is not the type that we did earlier where you could finagle the bases to somehow make them match up and then just get rid of them and equate the exponents. We have to actually use logarithms. The biggest, probably the most useful thing for you about logs is that you can solve equations with the unknown in the exponent spot. So like this first example, 19 to the nth power equals 45. If you think about it, it's got to be somewhere between 1 and 2, because 19 to the first is 19, and 19 squared is something big that I should know, but 45 is in between those. So we're looking for some number between 1 and 2 that I can put as the exponent with a base of 19 and get 45. Really, the only thing there is to this section is you want to know that the opposite of 19 to the something is log base 19. So what I want to do to both sides of this equation, I want to do the inverse of 19 to the n, which is log base 19. Whatever you do to the left, you do to the right. You learned that years ago. Okay, so on the left, you kind of can, once you get good at this, you'll probably just leave that first step out, because log base 19 of 19 to the n equals n. Log base 19 and 19 to the whatever, those cancel each other out. And my answer is log base 19 of 45. With or without the parentheses is okay. So here's an interesting place. Your answer, that log base 19 of 45, that is just some number, okay? You can leave your answer like this if you are on a non-calculator portion. If we want to find out what that number is, and we want to know it's somewhere between 1 and 2, but what is it? We need to be able to figure that out, and that's going to be a calculator issue. Now, a newer calculator, you should have a function in there where you can type in log base 19 of 45, and it will tell you what that is. My calculator is not a newer calculator, so I don't have that option on here. So what are we going to do about this? We're going to use what's called the change of base formula. And this is just a kind of a fast way to show how do you do log base 19 of 45. It looks like this. Log, let's go base b of c equals log c over log b. And that's assuming, this will work for any base, but this is assuming the understood 10. Now, why would we use 10 if we could use any? Well, the log button on your calculator is base 10. So what we can do basically here to get our decimal answer is do log base 10 45 over log 19, and that's going to give us our answer. Log 45, make sure you close the parentheses, divided by log 19. And there's that number between 1 and 2. We'll just call it 1.293. So on a non-calculator portion, or non-calculator test, there's your answer. Calculator, there's your answer. That change of base formula, we'll just leave it at that for now. We can talk more about it in detail, but basically, in a situation like log base 19 of 45, if your calculator is not new enough to calculate that for you, then just do log 45 over log 19 in your calculator. Works for any base, but since your calculator is base 10, we'll use base 10. All right, so these first few equations are nice and easy set up, just one exponential equals a constant. So what if there's some more steps to it? Let's just take a look at 5. On number 5, our exponential expression, 8 to the 8m, it's already by itself. I don't need to move anything over yet because I just have my exponential. So I'm going to log base 8 both sides. Okay, on the left, that leaves me with just 8m. And on the right, log base 8 of 12. Now to get m by itself, I'm going to divide both sides by 8. Log base 8 of 12 divided by 8. Again, non-calculator test, there's your answer. A calculator test where we want a decimal answer rounded off. We want to know what's log base 8 of 12 divided by 8. Well, log base 8 of 12 is log 12 over log 8. Close those parentheses after the 12, and then divided by 8 gives me 0.149, let's just call it 0.149. All right, you need to be okay with either the exact answer here or the rounded off answer here. And you should know we're solving equations. The fail-safe for any equation ever is to substitute your answer in and make sure you get a true statement. So if 8 to the 8m, and m is 0.149, would look like this. 8 to the 8 times 0.149, and this is going to be a little bit rounded off. I'm not going to get my 12 exactly, but I get 11.9, and it would have been 12 or closer to 12 if I had used more decimal points after the 0.149. But that's close enough to convince me that that's our right answer. All right, so exact answer, rounded off answer. Okay, so starting here, let's start with 9. Very common mistake when you start learning about logarithmic equations is to try to undo the 18 to the before you isolate it. You need to isolate the exponential. This needs to be by itself before we log both sides. Okay, so I need to divide first by 5. Isolate that expression first. Okay, you cannot do log base 18 of 5 times 18 to the n and get anything meaningful. I mean, that's a valid expression, but that's not the way you solve this. Get that 18 to the n alone first. Now, log base 18 on both sides. So are you comfortable now with that? Log base 18 on the left just gives me n. On the right, log base 18 of 8/5. All right, that's our exact answer. Our decimal answer, log base 18 of 8/5 will be log of 8/5 divided by log of 18. Log of 8 divided by 5 divided by log 18, 0.163. All right, exact, decimal, make sure you can do both. All right, let's get one with a couple more steps. Let's try one like 17. Actually, let's try one like 21. All right, solve this equation. I see my unknown value n up in the exponent location, which tells me automatically I need to use logs to answer this question. But like I said on the last one, do not log both sides until the exponential expression is isolated. You need to get rid of this +1 and this divided by 4 first. So I'm going to subtract 1, just like I would in Algebra 1 solving an equation. -15 minus 1, -16. Now I'm going to divide both sides by -4, just like I would have in Algebra 1. 12 to the 9n plus 4 equals 4. Now I can log both sides because the exponential expression has been isolated on the left. All right, I'm going to log base 12 both sides. Okay, that's that step I said you would probably start to leave out. The step I left out was this, showing that I did log base 12 of 12 to the 9n plus 4. If you are at all still shaky on that step, write it in there every time. Log base 12 and 12 to the whatever cancel each other out, just leaving the exponent. Now in this case, I had two steps within the exponent itself, so now I need to do another subtract 4 and then divide by 9. So 9n equals log base 12 of 4 minus 4, if I move that 4 over, and then n log base 12 of 4 minus 4 divided by 9. All right, so that's my exact answer. Could type it in again, just like I have been. I would do log 4 divided by log 12 to evaluate log base 12 of 4. Get that number, then subtract 4, then divide by 9. Okay, so there are lots of examples on this sheet. Okay, I'm going to scroll through them slowly. You can pause, you can write as many of them down as you would like. I'm going to suggest doing a few of these just so you're ahead of the game when you get to class. All right. Getting more difficult as we move through the list. We can take out, I didn't mean to give you these E ones, so we'll save those for another day. Don't do those. Accidentally got in here. But anyway, there are a bunch of problems. Pause and write down as many of those. And here are answers. So again, pause, write down any of these answers. Some of them have exact, some of them have decimal. Some of them we've already done, but there's plenty of practice. So practice a couple of those, add them onto your notes, and I will see you in class. Exponential equations requiring logs. Young out.